I'm again super excited about everything we're talking about. The next one is close and personal for me. I'm living in Brooklyn. Our office is in Manhattan. I pass the site for where this is going to happen all the time. We're going to talk to Jen Grosso and Prudence Ferreira, who are going to represent the ambitious and cool project. It's a NYSERDA Buildings of Excellence Round 5 winning project. It's at 475 State, and it's a huge mixed-use tower. Um, Brooklyn Alloy's block aims to be the tallest passive house tower and the largest FIAS Core certified project in the world. So, if that's not massive, I don't know what is. And take it away.
Awesome. Thanks so much for having us. I'm Jen Grosso. I'm the Director of Architecture at Alloy Development, and I'm also part of the Board of Directors at FIAS. And Prudence, you're mute.
Hi, everyone. I'm Prudence Ferreira, Vice President of Sustainability and Resilience at Thornton Tomasetti, as well as a FIAS board member and technical committee member. And thanks to Passive House Accelerator and the RB Collective. Speaking of massive impact, I remember back to when we started this collective during COVID with 300 people calling in every week from around the planet. And I just want to congratulate you, Mike, and PHA on its impacts. As you mentioned, today we're here to talk about the Alloy block.
And maybe first a little bit about Alloy for those of you who don't know us. We're a developer here in Brooklyn, and our firm is guided by a mission, and that's to make Brooklyn beautiful, sustainable, and equitable. While we're Alloy Development, a development company, we really take on an expanded role in our work. We do our own acquisitions, we source our own capital, we design our own projects, and we've done brokerage and construction in the past. We've recently started a management company. We're about 20 people, and most of us are architects, but we're also analysts, brokers, and engineers. And we think this integrated model offers a value proposition to our projects. The work we bring, it brings together all of these different ways of thinking about the environment, built environment together. Design value is coupled with public or urban value, is coupled with economic value in any development solution we propose.
And Thornton Tomasetti is a multinational, multidisciplinary engineering firm with a core focus really on climate action in every one of our engineering practices. We have close to 200 engineers, or 2,000 rather, collaborating in offices on multiple continents to help bring high performance projects like the Alloy block to fruition across the world. And while we have expertise with structural and facade engineering and sustainability consulting on many iconic high-rise developments all over the world, the Alloy block and the tower at 475 State Street includes the highest performance high-rise to date.
So just really quickly, a little bit of background on the block itself. It's a full city block in downtown Brooklyn. It's made up of 5 buildings, and across those 5 buildings, there's a mix of uses. It's residential rental, which is both market rate and affordable. There's an education component, a bunch of office space, as well as retail space. We're here in downtown Brooklyn. We're kind of on the eastern limits of what's a 2004 rezoning that was really established to encourage the commercial center of Brooklyn to come up. To our north, we've got Flatbush Avenue, which really reflects the built-up nature of this downtown Brooklyn. It's very commercial. And to our south, we have State Street, which is more of kind of your traditional, beautiful brownstone Brooklyn, think Boerum Hill. And just kitty corner, we've got Atlantic Terminal, which for those of you who don't know, is the second largest transit hub in New York City. And it just kind of gives a sense of the incredible transit-rich nature of this area. And in 2015, this is really when we started the project, we purchased our first little parcel on what is now the block, and we were trying to figure out what we wanted to do with it. So we approached our neighbor, which is the Khalil Gibran International Academy. It's a New York City public school, and it's administered by the Education Construction Fund. ECF, for those of you who don't know, is kind of this 1960s entity that's tasked with overseeing development of New York City's public school assets. And we approached them and we asked them if they want to see if they want to sell air rights, because schools don't tend to get any taller. But what we found out is no, their building's not accessible. They didn't have space for a lot of the facilities like a gym most schools need. It's not really kind of adequate for modern education. What they really wanted was a new school space. So we, with ECF, created a public-private partnership. And we went through the process of rezoning the block and adding density. We had over 120 meetings with different stakeholders. These are local electeds, community organizers, residents around us, to try to understand what people wanted in this area. And there's a couple standout things, right? One is more housing, that's especially affordable housing to support the development of the commercial area of downtown Brooklyn, and of course, additional school seats. And that combined with the transit-rich nature of the site was really the basis of the proposal for the development on the block. And importantly, the partnership kind of formed a critical financial mechanism for the development, in that the Education Construction Fund, as a public entity, has the ability to float bonds to raise equity for the construction of the school. And within the partnership, they own the rights to a portion of the market rate income. So over time, effectively, these rents are paying back bondholders, which was the construction or the capital used to fund the construction of the school. So really what this means is the development and the additional density on the site and the public-private partnership allowed the project to deliver 2 public schools for 0 taxpayer dollars. Just really quickly to go through the different elements of the block. The first is 505 State. This is a mixed-use tower with 440 homes. 10% of those are affordable and about 30,000 square feet of retail along its base. We've got our 2 public schools. This is PAS 456, which is a new lower school, as well as the new home of the Khalil Gibran International Academy and some retail at the base. And we're currently undergoing our second phase of construction, which we call 1/3 Avenue, which will be 582 units, which will be 20% affordable, some office, some retail, and some independent masonry retail buildings at the base. So just to kind of dig into some of the systems a little bit, 505 State is complete. It was New York City's first all-electric tower. And in kind of tandem with that, we are sourcing renewable energy from local community solar with the goal of becoming carbon neutral.
And the decision to make 505 State Street an all-electric building was actually sparked by the building's gas provider stopping new gas connections to Brooklyn. And concurrently, the New York City Council passing Local Law 97, which all of us by now should know, mandates a 40% reduction in GHG emissions by 2030. The tower's resilience strategies include protection from hazards posed to the community, such as extreme heat, cold, utility, and civil disruptions, but it's not quite passive house yet. In terms of the envelope, it does have a high performance facade, which includes triple pane glass, fixed windows and operable windows at around a 45% window to wall ratio, and a very well insulated building envelope, which improves the acoustics and the energy performance of the building.
And I think one thing interesting to note is while these systems for all electric buildings have been around for decades and are relatively simple, right? It's heat pumps, it's induction cooktops, it's an electric boiler. What is interesting is that the technology might not be new, but really the strategy or the communication was new at the time. The building's marketing proposal really centered the sustainability goals as, kind of the main kind of advertising that we had for the block, right? The tagline, carbon neutral living without compromise, was a huge part of it. And there were some questions from our capital partners early on, right? What will people think of induction cooking? Is there truly a rental premium to cover the additional construction costs? And what we saw when we were going through leasing is that we saw the highest rental rates for the neighborhood at the time. And when we surveyed our tenants, 50 to 60% of people who moved in actually really noted that this ability to live sustainably and like live through their value set was an important reason that they had moved in. So there's a business case here, right? At least for this catchment of renters, there's desire in the market, and people want to align their lifestyles with their value systems.
Also on the block are those 2 schools, including New York City's first passive house public schools. And no one came with a mandate here. Alloy, as developers and designers, imposed this on themselves as a goal, but it was one that really quickly established proof that passive house is achievable for public schools.
And this is just an image looking from State Street. The gymnatorium you can see on the lower is available to the community on off hours. Prudence, anything to add here?
Sure. So TT collaborated with Alloy and ARO and the facades team And on the next slide, we can see the optimized enclosure that we ended up with, the airtight envelope to maintain comfortable interior conditions and energy demands for both the schools and the building, with an R50 roof, Schuco AWS 90 SI fenestration at about a U.13, and a 60% window to wall ratio to balance energy efficiency and really fully light up the classroom spaces. We had R40 walls, R20 foundation, and of course thermal breaks, not only for the brick facade with the ferrosaf fast system, but also for mechanical dunnage and plate enclosure structure. That was a new one. Ventilation here was provided per ASHRAE 62.1 with ventilator units ranging in efficiencies from 60-50 sensible humidity split to 80-480 with Swagon units. And overall, the academy and the two schools demonstrated 40% energy savings from an equivalent 2016 NYC ECC compliant building. Multiple system options were studied by the School Construction Authority prior to selecting the high performance VAV system.
Great, and that's really where we are today, right? We've completed our first phase. It's the all-electric tower, it's the passive house schools, and we're fully occupied. This is us today, and we're really turning our time and attention to the second phase of development, which was freed up when Khalil Gibran International Academy moved into the new facility that we constructed for them. And we call this 1/3 Avenue. It's this kind of section down in the dark gray here. And our plan is to keep as much of the existing masonry as possible while gaining access to the site. We're going to eliminate a small link portion here. And we're going to construct a podium that effectively allows our different office and residential and retail tenants to have access across all three sides of the block. Upon that, we will then create 6 floors of commercial office and about 50 floors of residential units, which is really the meat of the passive house project we want to talk about. So we've a couple key challenges we're looking to solve through this project. One is how in New York City can we produce passive homes at scale, given the vertical factory in which the trades work in traditional New York City development? And 2, how do we deal with the complexity, particularly at the base of the buildings with all these overlapping programs and both old and new building components? In this view, you can kind of get a sense of that building podium, right? It's 3 distinct structures, it's technically 2 buildings, and it's a really important aspect relative to reflecting kind of like traditional horizontal development in New York City over time, as opposed to kind of the graphic or the design of a mega block. But existing buildings are leaky.
So as Jen mentioned, the level of complexity just of a mixed-use building, but also a mixed-use development, which is part adaptive reuse of that historic portion on the street, part new construction. It really has required some creative thinking on how our considerations of FIAS can be applied to the best result. First, we've got a double height space comprised of that historic fabric on the ground floor that is just not possible to air seal at all. Second, we've got elevator and stair cores connecting from the FIAS residential floors through the commercial and retail levels and to the lobby serving the residential levels, which itself is connected to that double height historic masonry space. So the puzzle that we have had to solve is how to test that FIAS enclosure, knowing that we're going to have significant leakage from the historic portion of the lobby up through the elevator cores and doors and trash chutes opening or passing through the non-FIAS levels. I'm going to let you all chew on that one for a few slides, and we're going to come back to it. As far as the building's stats, the juicy stuff, we've got an R42 roof, R30 custom fabricated spandrel panel walls with a thermally broken backpan system. Our fenestration is between U.23 and 0.25. Our energy recovery ventilators are at around a sensible recovery efficiency of 84-85% with humidity recovery between 81 and 85. We have a rooftop cooling tower that has waste heat recovered via a 60-degree Fahrenheit condenser water loop that feeds vertical water source heat pumps in the dwelling units. And the project was thrilled, as we heard before, to be a recipient of the NYSERDA Buildings of Excellence Award. And we really are hoping that what we present here today inspires other developers in New York and beyond to consider similar development goals. Now, when we look at our further performance, this is where Alloy's dedication to FIAS performance and a ton of teamwork from Front, Cosentini, ELEC, and UAG have positioned us. We're exceeding all criteria at 95% CD reconciliation. And our cooling load limit of 3.5 BTU per hour per square foot, that's our constraining criteria. So coming back to the question of how to test this shining beacon of performance and inspiration, going back to the start, like we heard from Lewis, passive buildings in North America, we started with single family homes. We know how to build single family passive homes now. The R values, the systems required, we know how to detail and test the airtight enclosure. We even have a prescriptive path now to accomplish this. And during construction, it's all more or less at your fingertips. As passive building knowledge, practices, and skills have evolved, we've learned to do multiple units. And as we heard from Lewis, the passive community learned to design and test those efficiently too. Here at 1/3, we have 11 or so units on each floor. We also know how to test mid-unit, mid-rise, and even shorter high-rises pretty well. But now we've got 50 homes, or 50 floors rather, of homes that are all stacked together. And this presents that question: how do we test to FIA standards, knowing that we have phased construction and we have phased occupancy? And it's not practical to pressurize 500,000 gross square feet of real estate at one time. So our project team worked together with feedback from the FIA's technical committee to come up with a floor-by-floor blower door testing approach for this building typology. This was piloted at a project we heard about before, the Winthrop Tower. Stephen Winters Associates is our verifier here. And so we came up with a plan where we first utilized the first 5 floors, where the verifier is going to help train the trades, get the air sealing process down, get the kinks out of the construction QC process. This is our sampling pre-qualification group. Then on the subsequent 5 floors, the construction team applies everything they've learned, and the verifier comes and tests all those floors upon completion. If they pass, we move on to sampling. On the remaining 40 floors, 1 and 5 has to be tested. So the builder notifies the verifier as the exterior enclosure of each floor is completed, and then the verifier decides at that point whether it's going to be tested or not. If the builder gets the notification, yes, we're going to test this floor, they put pre-designed temporary construction measures in place for the crane tiebacks and the construction hoists in place. Verifier comes to test. If no test is needed on that particular floor, they move up to the next floor. Now, once the building is topped out, the verifier is going to come back and test the residential lobby down on the first floor and the elevator cores that are now closed up, as well as sampling trash rooms and hoist and crane tieback locations that are now completed. This approach allows phased construction and phased occupancy of the lower floors to occur while the upper levels are being completed, and giving the project team really the peace to sleep at night with confidence the building is going to meet the criteria. Additionally, the FIA's compliance model is front-loaded with conservative, non-threatening leakage expected through the elevator cores, the stair core doors and mech room doors. And this allows us to account for the energy penalty associated with the eventual untaped test.
Excellent. This just gives you a sense of really what we're ultimately hoping to achieve, both from the outside and the inside of this project, then a view of the development when it's complete. And I think, yeah, that's kind of what we're after. And when we take a step back and we look at what the alloy block is delivering, it's more land it's more land for schools, new school seats, permanently affordable homes, and new environmental sustainability metrics. This is what we know that the block is delivering tangibly. But beyond this immediate benefit, there's a broader benefit here that the block is looking to deliver, which is to serve as a model for engaged development throughout the city and to further the collective value that the built environment has the ability to create when multiple stakeholders are taken into account. So that's it. Thank you.
Thank you so much, Jan and Prudence. Couple of quick things. Prudence,
Yes.
0-0. Surprised that you're on such an incredible project. Prudence has been around, especially in the accelerator, so long, and has been a wonderful advisor. And Jen, that was just, it's such an exciting project. I cannot wait to see it take shape. This is definitely embodies a massive impact, not just in the building, but all of the different pieces you're putting in place that others who are doing a similar building later will have the ability to follow. It's huge, it's exciting, and true to form for Passive House, you're sharing it with everybody. So kudos and thank you.